Good day, ladies and gentlemen. You are welcome to another chemistry class, and today we are going to be looking at hydrogen bonding. Okay, it's just another type of bond. So, what is hydrogen bond? Hydrogen bond is a dipole-dipole intermolecular bonding that involves hydrogen and highly electronegative elements, which is NOF. In bracket NOF, that is nitrogen, oxygen, and fluorine. So let's write it down. Hydrogen bond or bonding. So we say it is a dipole intermolecular bond that involves hydrogen and highly electronegative elements. And what are these highly electronegative elements? I call it NOF. NOF for short. What is NOF? N stands for nitrogen. O stands for oxygen. And F stands for what? Fluorine. NOF. So, what are the rules governing hydrogen bond? Before you can look at a molecule and finalize that this molecule is attracted by hydrogen bond, there are some rules or there are some things you might consider before calling it a hydrogen bond. So let's look at it. Note number one, or hash, there must be hydrogen. Yes, there must be hydrogen. There must be hydrogen in that molecule. If there's no hydrogen, it's not hydrogen bond. It must be between two or more molecules. Yeah, it must be between two or more molecules. The hydrogen bond must be bonded to NOF. Yes, the hydrogen bond must be either bonded to nitrogen or oxygen or fluorine. So in other words, it is not anywhere you see hydrogen in a compound or in a element, in a compound or in a molecule, you now start saying, oh, because this molecule has hydrogen, it's hydrogen bond. No, the hydrogen bond must be bonded to NOF. And that hydrogen bond that is attracted to the other molecules must also be bonded to the NOF. So these are the rules to ascertain that a molecule is what? Is hydrogen bond. Okay, let's look at examples. The first example here we have, let's go to molecule of water. Molecules of water. We have H2O. Okay, so a single H2O this is a molecule of water. A molecule of water is not hydrogen bond. A molecule of water is covalent bond. Remember, in our last class, we treated covalent bond, and molecule of water is what is held together by what? Covalent bond. But when a molecule of water is attracted to another molecule of water, for example, you have another molecule of water here. You see, this is negative, positive, negative, positive, positive. I talked about this in our covalent bonding, saying that this atom, which is oxygen, is negative because it is highly electronegative, and it attracted more electron to itself, making it negative, then leaving the smaller electron to hydrogen, making hydrogen positive. So positive attracts to negative. So in that case, this positive will get attracted to this oxygen. You see, one molecule and another molecule. Then this bond that's attracting these two molecules, this bond is what we call hydrogen bond. This bond is what we call hydrogen bond. This bond here is what we call hydrogen bond. It mustn't be one molecule of water. It can be also two, it can be many molecules. In fact, you know, when you bring your water in a cup, that cup you are seeing there, you have many thousands of molecules of water in that cup. So you have so many molecules of water. So this is how they are being bonded: negative, positive, positive. So you see, this hydrogen bond. Intermolecule. You can see the dipole, intermolecule. You can see the dipole. This pole is what we call dipole. Then it's between two molecules. Intermolecule between two molecules. But intra, one, within a molecule. For example, now you can see this one. This one is one molecule. This is intra. One molecule. You see this bond. This bond is not hydrogen bond. No, it's not hydrogen bond. But between one molecule and another molecule is what hydrogen bond, intermolecule, and this is the dipole. So intra, one. So this is the inter. Okay, so I've explained this better on. We have more examples. I've talked about hydrogen. You can also have example of hydrogen fluoride. Let me do for hydrogen fluoride, HF. HF is a covalent bond, but with under HF, then positive, negative. So this is hydrogen bond. You can see that these rules are applied. There must be hydrogen, there is hydrogen. It must be between two molecules. The hydrogen bond must be bonded to north. You can see the hydrogen bond is bonded to north. You can see, bonded to north. That is fluorine. This one is bonded to oxygen. This nitrogen can also be bonded to nitrogen. These three electronegative element is what gives us part of the use of this hydrogen bond. Let's look at the last example. The last example. That is ethanol and water. Ethanol and water. Okay, ethanol plus water. You can see our water here. Now, I kept this last because they said the last is for the best. If you look at this ethanol and water, you know, ethanol can dissolve in water, and ethanol dissolves in water because of hydrogen bond. Now, what part of this ethanol is involved in hydrogen bond? Because not all this part of ethanol is involved in the hydrogen bond. Irrespective of that, it has hydrogen all over, but it is not all the hydrogen that is involved in the hydrogen bond. Now, let's look at this. You see, this hydrogen coming to oxygen is a hydrogen bond. It obeys all the rules of hydrogen bond because the hydrogen bond is bonded to north. This one is bonded to oxygen. It's between two molecules. And there's hydrogen, so obeys all the hydrogen bond. Now, one person might want to say, hey, there's hydrogen here, and this hydrogen is attracted here. No, this is wrong. Why? This hydrogen here is not bonded to north. This hydrogen is bonded to carbon. So it's not bonded to north, it's bonded to carbon. Carbon is not part of the north. It must be bonded, the hydrogen bond that is bonded to the other molecule must be bonded to north. Okay? As you can see, this hydrogen bond that is bonded to this molecule is bonded to oxygen here. Oxygen is part of the north. That's either nitrogen, oxygen, or fluorine. But this hydrogen here that is bonding to oxygen is not bonded to north. It's bonded to carbon. So carbon, the electronegativity is not strong enough to form a hydrogen bond. So this part of bond is not hydrogen bond. So where's a hydrogen bond? This one is a hydrogen bond. So the hydrogen bond that is bonded to the other molecule must be bonded to the north. Okay, so that's why I left this last example. Okay, so I hope you have understood the concept of what hydrogen bond. So thank you very much. Subscribe to my YouTube channel, share the video, turn on the notification bell. Thank you very much.